Hi. I'm going to go over the practice test for test 1. Okay, so first problem. For each part, answer with the population, a sample, data, a statistic, or a parameter. To estimate the number of New Yorkers who smoke cigarettes, John surveyed 100 people. The 100 people are, well, there are a whole lot more than 100 people in New York, and so this is John's sample. Jane determined the average salary of the 5 janitors who work for Ed's cleaning service. The 5 janitors are, now here, in this kind of problem, the word "the" is a key word. Right? Nobody says found the average salary of the 5 janitors who work for somebody, unless it is all the janitors who work there. Right? So these 5 janitors are the population. Right? All the janitors. Jane determined the salaries of the 5 janitors who work for Ed's cleaning service. They are, in dollars, these numbers. Those 5 numbers are, well, those 5 numbers are numbers that were written down, values that were written down about each element of the population. These are data. Part D. For a month, Jesse identified every insect he could catch in his apartment. He found that 18% were spiders. The 18% is what? Well, now I think it's pretty clear that it's obviously a statistic or a parameter, depending on whether you think it was computed from a sample or the population. If you think he caught every single bug in his apartment for a month, then that would be a parameter. But I don't believe that. I think it is a statistic, because I think he missed most of the bugs. So he only got a sample. All right, last part. Jane determined the marital status of the 5 janitors who worked for Ed's cleaning service. She found that 3 were married, 1 was divorced, and 1 was widowed. What are these results? Once again, they are just data, something written down about each element of the population. Okay. Number 2. Indicate whether the data described is discrete or continuous. Remember how to determine that? First of all, the data set has to be a numerical one in order for discrete and continuous to make sense, and it has to be given by a description. So part A here, size of a painting in square inches. Well, you can have a painting of any number of square inches. You can have a painting of 12 square inches or 44 square inches or 152,000 square inches. But you can also have a painting of 17.66647 square inches and so forth. Right? Any number in a whole interval. Right? So this one would be continuous. The capacity of a car's gas tank. Now here we're not given the units as we were in the first one. Right? We're not given the capacity in gallons or cubic centimeters or anything. But it doesn't really matter. The units don't matter. The question is whether what is described is a whole interval of values or just individual values that would be dots, separated dots if you plotted them on a number line. But the capacity of a car's gas tank can be any number in an interval, right? It doesn't have to be just 1 gallon or 2 gallons or 12 gallons. It can be 12.7754 gallons or any number you like within some interval. So this is going to be continuous also. What about the number of angels that can sit on the head of a pin? Right? Well, you can have 0 angels, or 1, or 2, or 3, or whatever, but you can't have 1.5 angels, or pi over 3 angels, or anything like that. Right? So if you were to put the possible values that this is describing on a number line, right? Here's 0, 1, 2, all you would see would be these separated dots. This is discrete data. The number of raindrops that fall on Virginia in 1 year, well, that's got to be discrete also. You can talk about 1.5 raindrops, but you don't really talk about 1.5 raindrops falling. Right? The number of raindrops that fall is either none or 1 or 2 or something like that. The amount of rain that falls on Virginia in 1 year in cubic centimeters, that's different. Right? That could be any number from 0 on up. So this is going to be continuous. All right, this last one on this page. Which of the following are measures of central tendency and which are measures of dispersion? Remember that our measures of central tendency are the three M's, mean, median, and mode. So this is going to be central tendency, and that's it. All the rest are dispersion. Right? Dispersion, variation, spread, all the same thing. Okay, for the data above, find the mean, find the median, construct the 5-number summary, and so on. So all these things seem to have to do with the calculator. So the first thing you want to do is bring out your calculator and put the numbers in. So go to Stat, and then Edit, and put those numbers in. You can see I've already done that. And then to get this stuff, you want to use Stat, and then go over to Calc, and choose one var stats, hit it again, and there you have it. Right? The mean is 16.501, blah, blah, blah. I'm just going to round that off to, 16.5. Close enough. Find the median. In order to find the median, I have to arrow down. Let's do that. Right? And there you see MED, median's about 18.9. Construct the 5-number summary. Well, there it is. Right? Minimum, Q1, median, Q3, maximum. So you just write that out. And that's what I'm going to do here. 5-number summary would be 0.19, 15.27, 18.9, I'm rounding again, 22.1, 23.64. Now I'm supposed to construct a box and whisker plot. Remember what that is? That is just a pictorial representation of the 5-number summary. So first thing I want to do is I want to draw a number line underneath it, and that's going to have to go from, let's see, just above 0 to just under 24. So I'm going to choose a number line that goes from 0 to 25. Okay, so let's see. I'm not too good at this, but here we go. We'll give it a shot. Oh, this 0 is so far off I have to change it. All right. So this would be 5, 10, 15, 20, 25. Okay. Now I'm going to put in dots for each of these numbers. 0.19, that'll be about right there. 15.27, about right there. 18.9, 22.1, 23.64. So these here are the whiskers, and then I can draw in the box, often called a box and whisker plot. And then normally you want to label these points. Okay, so there's the box plot. Does 0.19, this value here, seem to be an outlier? Well, it looks like it to me. I'm going to say yes. Right? I think so. It's pretty far away from the rest of the numbers. Can't be sure because we don't actually, well, can't be sure because we don't have an actual numerical measure, but it sure looks like it to me. If 0.19 is an outlier, which measure of central tendency should be used to represent the data? Remember the rules? If the data is categorical or qualitative, you use the mode. That's a no-brainer because neither the mean nor the median can even be calculated in that case. You have to use the mode. If there's an outlier, or possibly two, you use the median. Otherwise, you use the mean. So here, if this is an outlier, it's the only outlier. So you should use the median. Assume that the data shows the amount of rain in millimeters for 6 different Sundays in 2009, and that you're interested in the rainfall for the entire year. Compute the standard deviation. Well, you're going to compute the standard deviation with the calculator. The question is, I'll just go back up. I still have this same screen on. the problem is you have two standard deviations. You have the sample standard deviation and the population standard deviation. You have to decide which one is wanted for this problem. Well, this is only 6 Sundays, and you are interested in all 52 Sundays for this year. So this is a sample of the Sundays, so you should give the sample standard deviations about 8.66. All right, let's go to the next one. Janet has found that the mean of her data is 101.3 and that the standard deviation is 14.7. What's the z-score of the data value x equal 117? For this, you just want to use the z-score formula, right? Z is x minus mu over sigma. Of course, you could have z is x minus x bar over s if you think this is sample data. But usually you write it this way. The formula is the same either way. Okay, so what are we looking for here? Our x value is 117. The mean is 101.3. And the standard deviation is 14.7. So I just take out my trusty calculator and I figure out what this is. And I should find, what should I find? I'm looking it up here. Oh, it's just about 1.07. Okay, what data point corresponds to 1.45? Well, you're going to use the same formula. Z equals x minus mu over sigma. But this time, you know z, and you're looking for x. So you just put in minus 1.45 is equal to x minus 101.3 over 14.7. Right? And that says x is 79.985 after you do some arithmetic. All right. On to the next page. There we go. The Grand Island, Nebraska School District administered the Iowa Test of Basic Skills to 4,696 students in 2007. Janelle's daughter's score put her in the 63rd percentile. So first of all, does this mean that the girl got about 63% of the questions right? It does not mean any such thing, right? Because percentiles, like all these quantiles, percentile only tells you about the rank of the data point or whatever it is. It only tells you how far up in the ordered list of all the scores Janelle's daughter is. So the answer to this is no. Right? It doesn't tell you that she got 63% of the questions right. To give you an idea some concrete idea of this, suppose the Iowa Test of Basic Skills had 100 questions on it and nobody got more than 50. Right? The highest score of anybody who took it was 50. You could still be in the 63rd percentile. What would that mean? That would mean that about 63% of the scores were lower than Janelle's daughter's score. Janelle's daughter's score, if you put the lists in order from lowest to highest, Janelle's daughter's score would be higher than about 63% of them. Okay, let's consider the following frequency distribution. Data values, this is ungrouped data. Right? We don't have categories here, we don't have intervals here, we have actual data values, and their frequencies. Right? So remember what this means. This means that there were 7 4s and 4 5s and 6 6s and so on. Okay, so first of all, I want to find the mean. Now, I could actually do this by writing all this out, right? What would I do if I wrote out this whole data set? I would put in 7 4s, and then I would put in 4 5s, and so forth. I could actually put that in my calculator and get everything I need from there. But I'm not going to do that. How would I find the mean? I would add up all these numbers, and then I would divide by the number of numbers. Right? I'm going to do that in a quicker way here. When I add up 7 4s, I get 7 times 4. When I add up 4 5s, I get 4 times 5, and so on. So I'm just going to put in a column right here for value times the frequency, right? Because that's what I'm really doing when I add this up. 4 times 7 is 28, and then I have 20, 36, 21, 40. Adding up all the numbers in the data set is the same as adding up all these guys. So what is this? This is 48, 84, 5, 145. And then finding out how many points are in the data set is the same as adding up all the frequencies after you have 7 of these and 4 of these and so on. So this is 11, 17, 25. So the mean is going to be 145 over 25. Give me 1 second and I'll look that number up. It turns out to be 5.8. All right, what about the median? Well, I have 25 numbers altogether. When you have 25 numbers, then the middle position, not the middle number, mind you, but the middle position is the 25 plus 1 over 2 position. Right? We don't really use this much, but there it is. That is, it's the 13th position. Right? So counting up in an ordered list, which we have here, the 13th number you come to would be the median. Right? So when I'm counting, first I'm going to count 7 4s, and then let's see, I'm going to count 4 5s. That would bring me to the 11th data point, and then the 12th data point would be a 6, and the 13th data point would be a 6. So the median is 6. Find the mode. The mode is the data value or interval with, in this case, data value with the highest frequency, and that obviously is 4. 4 occurs more often than anything else. So the mode is 4. Now, let me emphasize that the mode is 4 and not 7, because if this were a multiple choice problem, you can bet that both 4 and 7 would be choices, right? So making it very easy for you to make this mistake of saying that the frequency is the mode, but it's actually whatever has that for highest frequency that is the mode. All right. Decide whether each of the distributions shown is closest to a uniform, symmetric, bimodal, skewed left or skewed right distribution. Let's see, let's do the easy ones first. This one certainly looks bimodal to me, right? It looks like there'd be a lot of data over here and not much in the middle, and then a lot of data again. So I think if you made bars, you get a high bar over here, very low bars in the middle, and then high over here again. I think this is closest to bimodal. This one's a little harder to see. This one looks symmetric to me. Again, thinking, I didn't put in enough M's, but all right, symmetric to me. Thinking of what the histogram would look like if you made one, it would have high bars in the middle and lower bars on each side. This over here, oh, this one's easy too, right? There's a whole mess of data on the right, very little on the left. So this one is skewed left. And finally, let's see, this one, I don't see any real pattern here. I'm going to say that this one is closest to uniform. All right. Onward to problem 9. Jerry measured the actual amount of soda in 241 12-ounce bottles and constructed the following relative frequency histogram. What are we supposed to do? Construct the frequency histogram for this data. Okay. What does the relative frequency histogram have here? Well, in each of these classes, we've got a bunch of classes on the bottom. This shows, this is the class 11.6 to 11.7 ounces of soda, and then there are bottles with 11.7 to 11.8 and so forth. Okay. In the frequency histogram and the relative frequency histogram have exactly the same thing on the horizontal axis. So that's what's going to be over here. let's see. I can't really fit that. I'm going to call this category A, B, C, D, E, F, G, H. So I'm just going to put A, B, C, D, E, F, G, H here. Right? They're exactly the same labels. I can't draw them here so that they'll be legible. Okay, on the y-axis, instead of percentage of bottles, as this relative frequency histogram has, this will actually have the number of bottles. Right? Because this is going to be a histogram, not a relative frequency. It's a plain old frequency histogram. So let's see what those numbers are. Well, it says here that I'll have to make estimates in making the frequency histogram. Let's see, well, this is certainly going to be 0 down here. No bottles. And then how high will this have to go? Well, it looks like the highest bar here is 35. 35% of the bottles Jerry measured had between 11.9 and 12 ounces of soda in them. So 35%, so that, let's do this. I would say 0.35 times 241, it's about 84.35, so I would say 84 bottles, 35% of the 241, 84 bottles. And so that's as high as this needs to go. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to make this 100. Right? Let's see, this will be 80, 70, 60. It'll be nothing of the sort. No, that's right. 70, 60, 40, 20. Okay, good enough. Right? I can already put in that middle bar there. What was that? That was my bar D, the highest bar. And it's going to be 84. It's going to be right around there. Right? That's going to be the highest bar. And all the rest of the bars are done in the same way. Right? This first bar here, for category A here, looks like that's about 2%. Right? So if I do this, if I do 0.02 times 241, I get about 4.82. I'm going to say that's 5 bottles. Right? 5 bottles for category A. Right? So there we go. And similarly, category B, let's see, I have these numbers somewhere. This works out to be just about 10 bottles. And then category C works out to be 24 bottles. So somewhere around there. Category D, we did the next one about 82 bottles. And then, oops, messing up here. And then about 19 bottles after that. 19. And then, again, about 5 bottles for this category. Oops, I missed something, didn't I? A, B, C, D, E, F, G, H. A, B, C, D, E. Okay, D and E, F, and then 19 point, yeah. Oh, okay. So that'd be 5. Okay, I missed one. When I was calculating before. Oh, it's about 12. So this one's about 12 bottles. And then this one's back to about 5. So this is what the histogram would look like. It looks exactly the same. The shape is exactly the same. All that's different is you have the actual number of bottles on this axis and the percentage of bottles on this axis. All right. Number 10. The table below shows the number of sheep with each marking color that Chevron observed on the hill yesterday. Right, so what we had some pink sheep, blue sheep, and then sheep with no marking. What is the mode of this data? Again, the mode is the category or data value with highest frequency. It's not the frequency. See, this is a multiple choice question, and Pink and 56 are both choices, because obviously pink is the mode, right? But it's pink that's the mode and not 56. That's just intended to warn you away from that mistake. Problem 11. A TI calculator was used to compute summary statistics for a particular data set with the results shown below. First of all, what's the range of the data? Right? Range is just max minus min. So this is 1.362 minus 0.851. 1.362 minus 0.851. Looks like it's 0.511. What is the interquartile range? The interquartile range is just Q3 minus Q1. Q3 minus Q1, 1.07 minus 0.899. Is 0.171. Right? Not much to that. Just have to remember what those things are. And of course, you're going to have notes in front of you, so it's not hard to look up. Okay. Number 12 here is one of these GPA problems. Last semester, Jackson got a C in English, a B in snorkeling, a B in psych, a C in biology, a D in French. Snorkeling was 1 credit, biology was 4 credits, everything else was 3 credits. What was his GPA to the nearest 100? All right, so I always do these the same way. Right? I make a little table. I need a column for class. So what are the classes? English, snorkeling, psych, biology, and French. And then I need a column for the grade. Let's see, he got a C in English, a B in snorkeling, a B in psych, a C in bio, and a D in French. And then I put in a column for the grade value, right? That means, 4 for an A, 3 for a B, and so on. So this would be 2, 3, 3, 2, 1, right? Now I need a column for the number of credits for each class. Let's see, what were we told? Snorkeling is 1 credit, and biology is 4 credits. Everything else is 3. Okay, and now I need a column for calculation here. I need grade value times number of credits. Right, so 2 times 3 is 6, and then 3, 9, 8, 3. And now I can compute the GPA. All I'm going to do is sum this column, and then I'm going to sum this column. I'm going to divide that sum by that sum. So what is this? 9, 18, 27, 30. Did I add that up right? 11, 20, 29. Woo. And then this is, let's see, 4, 7, 11, 14 credits. 7, 10, 14. Oh, good. I did do that right. So the GPA here is 29 over 14. And let's see, 29 over 14 gives us, can we see that? 29 over 14, 2.07, close enough. That's to the nearest 100th as the problem required. All right. 13. Jan asked a number of people to estimate the average number of steps they took each day. This table, that you can see here, summarizes the responses. If a histogram were made from this table, first of all, what shape would it have? Well, I think that's pretty easy to see. If you think of the histogram, there'd be a lot of high bars on the left, right? 36, 32, 32, 18, 8, and then there'd be blank spaces, right? Nothing at all, and then a very low bar for one person who walks an awful lot. So this thing is definitely skewed right. Would it show an outlier? Yes, it would, right? Because we consider if there's a single value out here, or maybe two if it's a large enough data set, right? If there's a single value out here and there's at least 2 bars of empty space between the main body of the histogram and the single value, we think it's an outlier. Okay. The standard deviation of a certain data set is 176.89. To the nearest hundredth, what is the variance of the data? Remember the standard deviation, that's S. So S is 176.89. Right? And if you had the variance is called S squared. Right? How would you get the standard deviation? S. You would take the square root of S squared. So if you have S and you want S squared, then you need to square S. So this says that S squared is 176.89 squared, which works out to be some number. What number is it? 31290.0721. There you go. Now that's the variance. Square the standard deviation to get the variance. Take the square root of the variance to get the standard deviation. All right, what about this last one here? What is the mode of the data set represented by this histogram? Well, it looks to me like the 2 highest bars are orange and blue. They have equal heights. And so this is bimodal. Right? Those heights are higher than anything else. And the mode is orange and blue. Right? You report both if it's bimodal. All right, that's it for the practice test for test 1. Good luck on the test.